Welcome to statistics class. This is our lesson, probability and probability distribution. Our topic is fundamental principle of counting. First fundamental principle of counting is sum rule. Suppose that an event can be performed by either of two different procedures with m possible outcomes for the first procedure and n possible outcomes for the second procedure. If the two sets of possible outcomes are disjoint, then the number of possible outcomes for the event is m plus n. So remember, this is the number of possible outcomes. Take note that having sample space is different from the probability value. So example, your sample space in a die is 6 faces. You can have 1, 2, 3, 4, 5, 6 in a different side. But in computing for your probability, let's say number 2, it can have a probability of 1 over 6. So take note of that, the difference between the sample space and your probability value. So let's have an example. So a scholarship is available, and the student to receive the scholarship must be chosen from the School of Education, Engineering, and IS students. How many different choices are there for the scholarship if there are 15 qualified students from Education Department, 20 qualified students from Engineering, and 10 qualified students from IS Department? So we have 15 plus 20 plus 10 ways to choose whom to avail this scholarship. So that is the sum rule. Let's proceed to product rule. It states that if a thing can be done in m different ways and another thing can be done in n different ways, then the two things can be done in m by n different ways, or m times n different ways. For example, Gracia has a choice of 5 sandwiches and 6 juices. In how many ways can it choose one sandwich and one juice? So there will be 5 times 6 equal to 30 ways to choose. Example, sandwich 1 or juice 1, sandwich 1 or juice 2, sandwich 1 or juice 3, sandwich 1 or juice 6. So all in all, you can have 30 ways to choose, or Gracia has 30 ways to choose. And then another one is factorial notation. So it can be small n and then looks like exclamatory point, or big letter N, which read in statistics or in mathematics is n factorial. It is the product of the first n consecutive natural number. So n factorial is equal to n multiplied to n minus 1 multiplied to n minus 2 multiplied to n minus 3 ellipse until 1. So example, we have 4 factorial is equal to 4 times 3 times 2 times 1 is equal to 24. You can try it in your scientific calculator. 4 factorial, it is also equal to 24. Let's proceed to permutation. What is this permutation? It is an arrangement with specific order. So it is defined as an ordered arrangement with a finite number of elements, either all of the available n elements or of a part of them. So the permutations that contains exactly the same elements but not in the same order are as different. Okay, so the number of permutations of indifferent things taken r at a time is computed, or this is mathematical presentation, and p, which signifies your permutation, and then r at a time or taken at a time is equal to n factorial over n minus r factorial. So if taken all at once, it can be n factorial. So remember, this is with the arrangement with specific order. That is permutation. So permutation with identical elements. So the number of permutation is reduced when a collection contains identical elements. So the number of permutations and objects P of one type, Q of one type, S of another, etc. is given by the permutation with identical elements NPR is equal to n factorial over n minus r factorial multiplied to p factorial another type, another q factorial multiplied to s factorial, and then etc. or is equal to n factorial over p factorial. This is another objects, q factorial, s factorial, and others. Cyclic permutation. It is a shifting of an entire order of elements one or more steps forward or backward. So the first element taking the position of the last or vice versa without changing the order of the elements in the sequence. So this is called cyclic from the word cycle, permutation. So n Pn is equal to n minus 1 factorial. But you will understand it deeply or further discussed in your probability subject. And reminder, this probability has something to do with your sampling techniques and your statistical analysis. And then the combination. It is an arrangement with no specific order. So, for example, in permutation, 1 and 2 is different from 2 and 1. But in combination, the arrangement doesn't matter. So, okay, it is an arrangement of the selection of object regardless of the order. So the number of combination of n different things taken r at a time is n combination r, or n taken r is equal to n factorial over n minus r factorial multiplied to r factorial. So if you will take it all at once, it is 1. Okay. Now let's proceed to the combination of n objects taken 1, 2, 3, ellipse until n at a time. So it is equal to 2 to the power of n. This is their number of objects minus 1. So thank you so much. See you in our next topic, normal distribution. God bless you.